Hello viewers, welcome back to our channel. I remain Shaka Annual, the math tutor. Today we will talk about singular points. I will talk about power series solution under chapter 5. And we note that at the start we said the solution to a differential equation at point x depends on the nature of that point x. We can only solve for this equation using power series solution if it is analytic at that point x. I'm saying that the solution to our differential equation using power series solution will depend on the nature of the point x, this point x. Now we can only solve for this equation, this differential equation, if our solution, or if our differential equation is analytic or defined at a point x. And now here this drives us to singular and ordinary points. Now let us consider a second order differential equation, a2x y double derivative plus a1x single derivative plus axy equals to 0. This is the second order differential equation. You see now, a point x is said to be a point x in the interval of convergence is said to be an ordinary point. Remember, I'm saying we're finding an ordinary point. We're saying that, and a point x in the interval of convergence x is said to be an ordinary point if the rational functions, these rational functions, a1x, a over a2x, and a0x, a2x are both analytic or defined at this point x. I'm saying that, I'm coming again that a point x is called an ordinary point in the interval of convergence if these two rational functions, a1x, a2x, and a0x and a2x are both analytic or defined at point x. I mean that if I have a differential equation like this one here, my task is me allocating a1x and a2x, I divide them, and then a0x and a2x, I divide them. Now, the values that will make the function defined at that point are going to be called my ordinary points. Now, likewise, if any of these rational functions is not analytic at the point x, as in if this rational functions is not defined at the point x, any one of them or both of them, that point x is called a singular point. I come again that if I obtain my rational functions in a1x over a2x and then a0x over a2x from this differential equation, and the points that will make that function undefined, that's what we call our singular points. And then we classify our singular points. We classify these points that will make this rational function undefined into two terms. We have the regular and irregular points, the regular singular points. Now, if a point x is said to be irregular, first of all, it has to be singular, and the functions now here we have these also two functions. We want to classify our point x, which is singular. Is it regular or is it irregular? Now from there, I shall always conclude that a point is going to be regular. Our singular point is going to be irregular singular point if x minus x naught a1x over a2x and x minus x naught squared a naught x over a2x, all these functions are defined at that point x. Now, if one of them or both of them is not defined at that point x, then the point x becomes an irregular singular point. I think for this, you need to master this content in your head, and then you'll be able to solve and locate singular points and ordinary points for a differential equation. But keep in your head that you shall always solve a differential equation at ordinary point, because we shall solve a differential equation using power series when at that point the equation is analytic or defined. But now they may ask you to locate the ordinary point or singular point, and then they tell you to describe the singularity of the given points, the singular points you've got. Now, allow me put off this, and then we see how we can do an example to locate the ordinary points and the singular points, and then we determine also the nature of the singular points. Now, if I put off this first, I'll get an example. An example, we have our example we have today. You say they're telling us question saying Locate the ordinary points and singular points and classify their singularity. Locate. Our question today is telling us to locate the ordinary points and stationary, the ordinary and singular points and we classify the singularity of these points we've got and classify the singularity of the points we've got. Now, from our question, our differential question is given like our differential question is like is given by x squared into x plus 2. Now y double derivative plus 3 x minus 2 y single derivative plus 1 equals to 0. I think now from here we just need to master what we said. We should say that a singular point, we classify an ordinary point or singular point if our rational functions are all defined at that point x. Therefore, my task is to get my rational functions. Now, if I want to get my a, what is my a2? My a2 is the coefficient of y double derivative. It's the same as having x squared into x plus 2. What would be my a1? My a1 is the coefficient of y single derivative. Same as having 3 into x minus 2. And then what's going to be my a0? But x is the same as having 1. The coefficient of this y here is 1. Now, my task is me finding a1 at x divided by a2 at x. Now, a1 at x divided by a2 at x, what's the solution here? I'll have 3x minus 2, then over x squared into x plus 2. And then what is going to be a? This is going to be a naught x out of a2 x, same as having 1 out of x squared into a plus 2. Now, we say that we shall always have the singular points when these two, we shall always have our ordinary points when these two rational functions are defined. Therefore, we shall always just look for the values of x that will make these two functions undefined, and then we shall be able to get the singular points and get the ordinary points. Now, if I look at this first equation here, this first function, or a rational function here up, what values of x will make it undefined? From here, from the denominator, if I got the denominator to 0, for me to get something undefined, I have to have something over 0. And if I set x squared into x plus 2 equals to 0, then I'll get that x equals to 0 as my first value, and then x equals to negative 2. Therefore, these two values of x equals to 0 and x equals to negative 2, for this function will be undefined. Therefore, all other values of x excluding 0 and negative 2, that function is going to be defined. Therefore, our singular points for this function are going to be 0 and negative 2. Likewise, for this second case, suppose the is the same thing. Therefore, just conclude that our singular points are the values of x that make the function undefined. Then our singular points are x equals to 0 and x equals to negative 2. That way. Then what will be our ordinary points? The ordinary points are going to be all real numbers except 0 and 2. Are we together? We are saying our ordinary points are going to be 0 and 2. All real numbers except 0 and 2, and then our singular points are going to be 0 and negative 2. Because 0 and negative 2 make these two functions undefined. I think we are together. Now my second part is for me classifying the singularity of these points we have got. You know, I put our two singular points as x and x. Our x not as x equals to 0 and x equals to negative 2. Now my task here is to identify and describe how these points are they regular singular points, or is x not a regular singular point, or is x2 a regular singular point. Now, how do we classify? Remember, we say that we shall always classify using also the functions. If the functions, if these two both functions are defined at that point x, then we shall say that function is that point is a regular. Now, if one of them is not defined at those functions, or just that function is not regular, that is irregular. Then, for us to classify singular points, if I put off this, I think this one is fine. If I put it off. Now, we are saying that classifying singular points, I want to classify our singular points we've got. Remember, singular points we have both, they have to be, they may be regular and then regular and irregular. Now, we say that our functions, it has to be x minus x naught, then a1x out of a2 of x, and then you have to have x minus x naught squared into a naught of x, and then a2 of x. Now, we have two singular points. We have our singular points are two. Our singular points, we have our two singular points. We have x equals to 0 and x equals to negative 2. Now, we have to examine both of them and we see what is the singular, what's going to be our regular singular point and our irregular singular point. This is x equals to negative 2. Now, let us begin. Let's begin with x. When x is 0, what's going to be when x is 0? When x equals to 0, what's going to be x when x equals to 0? If I put in x equals to 0, I have here, so when x equals to 0, I'm saying it's 0, I'm writing 2. When x equals to 0, I have now x minus 0, which is x. This first rational function is going to be x minus 0, which is x. Now, a1, so the a1 is this 3 into x minus 2 over, now, a2 is now x squared into x plus 2. Now, the honest one, this one is how I'm with 3 into x minus 2 out of x into x plus 2. Now, if I put in my x when it's 0, this function will be defined. I'll have 3x minus 2 divided by 0, which is going to be undefined, not analytic. At x, this function of ours won't be defined when x equals to 0. Because if I put in x equals to 0 here, I'll have 0 as the denominator. Therefore, it's going to be not analytic or not defined. Or not defined. Now, from me getting one of these ratios not defined, I just conclude that that function is an irregular singular point. But then I can also check this second function also to see is it defined or undefined. But for me, just getting one of them not defined is enough for me to conclude that something is not defined. But for if I one of them is defined or analytic, I have to look for the second one, because both of them have to be defined for it to be a regular singular point. Now since for now I've got one of them as at x equals to 0 and one function is giving me not defined, therefore just call that x at x equals to naught. This is my irregular singular point. But I can also go ahead and look for when I put in here now when x equals to 0 for this second function to see how it behaves. Now when x equals to 0, I have x squared now because it's squared into a naught is 1 out of x squared into x plus 2. Now this one will cancel this one. I remain with 1 over x plus 2. And then here, if I put in x here, I will have a half. If I put in my x equals to 0 here, I have a half, which is defined. But since one of these two rational functions has been undefined, therefore I'll conclude that my x equals to 0 is going to be an irregular singular point. Then, now if we go for x equals to negative 2, so when x equals to negative 2, yeah, when x equals to negative 2, I do the same case. I first come, I feed into this first function, I say, when x equals to negative 2, I have now x, I have, when x equals, I have now x minus x naught, which is negative 2. Then I have plus 2. Now into my x1 is going to be 3 into x minus 2, then out of x squared into into what? Into x plus 2. Until I say comes with this one, then I'll remain with 3 into x minus 2 over x squared. Now, when x is negative 2, when I have negative 2 here down, this one is going to be defined. Therefore, this is going to be defined or analytic. Because when x is negative 2, I want to have a 0 down here. Therefore, it's going to be defined. Now, if I put, since it is defined, I cannot just conclude that this function is going to be a regular point. I have to also check for the second one to see that it is also defined. If both of them are defined, then I can conclude that it is a regular singular point. Now, for the second one, I'll have now x minus x. I have x minus x naught, which x naught is 2, negative 2. I have now x plus 2 squared. Now, into our x1 is, our a naught is 1 from here, and then our 1 is going to be x squared, then into x plus 2 again. Then 1 will go with 1, then I'll remain with something like x plus 2 out of x squared again. Now, if I put in my x equals negative 2 in this function, I have x power 4. I have 4 down here, which is negative 2 squared, which is 4 here. Therefore, this function is going to be defined because it is not 0 here down. Therefore, also this is defined. Now, if both of them are defined at that point, I just conclude that x at x equals negative 2, this is what we call a regular singular point. I think with this, you can be able to locate and see different singular points and ordinary points and classify their singularity. Members, thank you for watching. Share the videos to other people so that they can enjoy this video of mathematics. Like, share, and comment as we go ahead with chapter 5. Allow me in the next video, and now I'm going to show you how we solve a differential equation using power series solution, because you have seen what we need to have as the introduction part. Then next part, we shall now be solving the power series solution in the next video. Thank you for watching. I am Shaka Annual. For any mistake or for any inconvenience you have caused, just put in the comment section. I'll be able to answer you right. Thank you for watching.